This one. Okay, let's start. Hello, everyone. Welcome to IIT-JAM Chemistry tutorial number 51, and this is lecture number 9 of the physical chemistry chapter solid state. The subtopic of this lecture number 9 is close packing in metals and metal compounds. And in the second part of this lecture number 9, we are going to discuss metal compounds, rock salt, and caesium chloride. Before starting, let's have an idea about the chemical bonds. There are three types of chemical bonds: metallic bond, electrovalent bond, and covalent bond. When one electropositive element is bonded with another electropositive element, then metallic metals or alloys are formed via metallic bond. When an electropositive element is bonded with an electronegative element, then ionic compounds are formed via electrovalent bonding. And finally, when an electronegative element bonds gets bonded with another electronegative element, then covalent compounds are formed by via covalent bonding. Now, ionic solids are actually some inorganic salts, which are made up of metallic cations and non-metallic anions, and they follow some particular crystal structures such as rock salt, caesium chloride, sphalerite or zinc blende, wurtzite, fluorite and antifluorite, rutile and trirutile, beta cristobalite, nickel arsenide, perovskite, and finally spinel. So let's start with rock salt. Rock salt is actually sodium chloride or potassium chloride, or there are so many compounds where one cation is surrounded octahedrally by six anions and vice versa. That means one anion is also surrounded by six cations. Here, look, this is the cation which is surrounded by six anions octahedrally. On the other hand, this anion is surrounded by six cations. Let me count: one, two, three, four, five, and six. Don't take into consideration this one. This is not in the close neighborhood. Okay, these six are forming the octahedron. So the coordination number is 6 and the radius ratio also supports this face-centered cubic lattice structure, and it is 0.414 to 0.732. Coordination number 6, and if you divide this into 8 small cubelets, then this type of arrangement is found, which is actually for this rock salt structure. Here, alternate apices are occupied by the either the anions or the cations. That means anion, cation, anion, cation, anion, cation, anion, and cation. Now, the solids which follow this crystal structure: rock salt, sodium chloride, potassium chloride, magnesium oxide, calcium oxide, strontium oxide, barium oxide, magnesium sulfide, calcium sulfide, strontium sulfide, barium sulfide, silver fluoride, silver chloride, and silver bromide, and etc. So many others. So that's all about the rock salt structure. Now move on to caesium chloride. Caesium chloride is body-centered cubic space lattice where one cation is surrounded by 8 anions and vice versa. That is, one anion is surrounded by 8 cations. And the radius ratio is 0.732 to 0.999 or 1.000, which supports 8:8 coordination number. And the ionic solids with caesium chloride structure are caesium chloride, caesium bromide, caesium iodide, thallium chloride, thallium bromide, thallium iodide, and ammonium chloride. How? This is not a metal. This is actually some not complex, non-metallic cation. This is ammonium ion, NH4 plus. Then how it fits into this structure? Look, here's the structure. In place of caesium, the ammonium ion is there, and just like methane, the nitrogen hydrogens are oriented towards the apices of every alternate corner of this large unit cell, main unit cell. Okay, this is the straight line: nitrogen, hydrogen, then chloride. Okay, this is another straight line: chlorine, hydrogen, nitrogen. So this is also this type of structure, which is ammonium chloride, and it resembles the caesium chloride structure. So that's all about these two structures. Thank you and have a nice day.